you very much for the introduction, and thank you, Minister, for a very nice opening speech. It's good to be here. Last time I came to Mumbai, I was with Barclays. That was almost a year ago. Now I'm back to my prior company before Barclays, and I have moved back to Silicon Valley from London. So what I'd like to talk about today, and I'm hoping I will consider this a failure if you guys don't ask any questions at the end. So if you don't ask me questions, I'm going to ask you questions. So please prepare good questions. I hope to say a few things that are controversial. This topic needs a lot of attention. There's a lot of great stuff happening here at Aegis, but in general, this is a topic that is going to change the world. I'm going to talk about the economic opportunity and some of the economic drivers behind data science and big data in particular. So what we will talk about is big data all around us, some of the issues that come up. Why is it that companies are actually moving to this platform for economic reasons, and the chaos that this leaves behind, and the real issues that you have to deal with once you as an organization make that move, which is a much needed move. I'll also, of course, illustrate this with a few case studies, both from Barclays as well as from other places. I think this screen here is not advancing, but that's okay. We'll use this screen. So you might ask, why should a bank like Barclays care about big data, right? Why does this matter? Well, in the old days, the front office or the branch was sort of the intimate place where the branch manager, the staff, and so forth knew their customers. So what does that mean, knew the customer? It means they knew who was a good credit risk. They knew when it was a good time to extend a loan, when it was a good time to try to pull back. They knew when somebody was graduating, when somebody was trying to buy a farm, when somebody was trying to buy a horse, etc. That knowledge got lost when banks went to scale. And what happened now is in the front office, there's a lot of expenses and costs being spent on something called KYC, which is just know your customer. Back office, risk computations, literally, the big banks are spending hundreds of millions of dollars a year each, just on the costs of trying to assess the risks. Now think about that money. Think about how much we're talking about here and multiply it by the number of large banks around the world, which is significant. And you'll sort of understand the opportunity of using big data to try to understand what a customer is all about, what interactions they have with a customer, and really get to a point where each opportunity, each interaction is utilized either to learn something or to come up with an action. An action could be, here's a cross-sell, here's an upsell, here's a service, here's a piece of information, etc. This is a busy slide, but the basic idea is to get to a point where you can exploit all the data that is available, proliferate the analytics so that everybody uses them, and drive significant business value. Now, we'll come back to these three at the end and see whether this is happening or not. Okay, so in the world of e-business, this has been happening for a while. So you hear about Amazon, and I'm sure Flipkart here, and many other companies where a lot of the information online has been taken advantage of. The benefits, though, extend far beyond marketing and the sales cycle. However, you will be hard-pressed to find good places where we've seriously applied sort of all this wealth of data to problems beyond that, and we'll talk about that. If you think about, for example, Netflix as a service for videos, right? Recommendations, personalized recommendations, is an essential part of the service. In fact, a quote from Netflix, they claim that recommendations saves them about $1 billion a year between the good customer experience, saving extra searches, finding the right things, etc. So a lot of companies online have actually adopted this and have realized value from it. This has not happened offline yet, but it is happening, and we'll talk about why it's happening. Another example is from Disney, where they basically decided, simple idea, right? Utilizing the IoT, Internet of Things. Well, why, instead of people carrying tickets and maps, why don't we just have them have a wearable device? And the benefits have been, they had a significant investment in it, 99% take up by the guests, right? Fourth largest distributor of wearables in the world, wearable electronics. Transaction time down 30%, labor resource management improved by 20%. And we'll talk about some examples like these in detail as we go through. So basically, the challenge to harness the power of this data is there. And we'll use many examples of where the challenge is. And many organizations, unfortunately, are not taking advantage of it and actually are literally being submerged in data and not knowing what to do with it. So if you go to a company, you go to a business, and you say, what do you want from the data? The typical answers are, I want it to be reliable, affordable, timely, accurate, comprehensive, unified, accessible, easy to understand, easy to embed into the business. And unfortunately, in most businesses, quite the opposite is true. We will talk about why. We will talk about reasons to sort of avoid this and fix this. But in general, it's unreliable, very expensive. Most people don't believe it when you find it because they'll tell you there's quality issues, numbers are wrong, incomplete, missing lots of critical information, difficult to get, unusable, etc. Big data is a new generation of tools which can help solve this problem affordably, right? And we'll talk about that. Now, at the same time, it can help make this problem much, much worse. And we will talk about that. So here's an architecture that we started with at Barclays, actually, driven primarily by cybersecurity, right? So the Chief Information Security Officer, Troels Erting, came to me and said, I'd like to be able to grab data from all over the bank, right? From social media, from application logs, customer interactions, trades, network traffic, applications, etc. Put it all together and analyze it. Looking for, of course, anomalies and being able to trace back through events that happen. Now, we started building this and called it the Central Data Fusion Engine, and we used open source and big data and Hadoop, and we'll talk about that in a second, to build this. The thing that's interesting about it is once we started building it, we realized that the same architecture, the same approach, actually services many other needs in the bank, including compliance, trade monitoring, fraud, financial crime, marketing, operations, payments, settlements. Banks do a lot of data operations manually, right? A lot of things like changes of addresses and settlement instructions and so forth, and risk in banks. So that same architecture essentially maps to everything else, and it became effectively a blueprint of how to approach a lot of these data problems. And a lot of them ended up needing the fusion of different types of data. And that was one of the key drivers to sort of adopt the technology. Big data is a new term associated with a mix of structured, semi-structured, and unstructured data. It typically breaks the barriers of relational database storage. Systems don't know what to do with sort of this mix of data. And it leads to messy situations with no standard recipes for how to handle it. And that leads to this term, data scientist. No good definition of this term. I like the definition that says it's someone who knows a lot more about statistics than a typical software engineer, and a lot more software engineering than a typical statistician. That combination is very rare. And that's why data scientists are in huge demand out there. And in the technical fields, they're probably some of the highest paid people. Actually, one of the studies by Glassdoor, which studies sort of jobs and so forth, rated data scientist as the top job in 2016 in the US. right? It shows you median salaries and so forth there, but more importantly, I was actually curious, if these are the best jobs, what would be the worst jobs? So the careers pulling down the median were reporter, mental health therapist, and tax accountant. So it's good to be on the other side of the spectrum, I guess. In big data, people talk about the 3 Vs. I'm assuming the audience here knows what they are. I will talk about the 4 Vs, but volume, easy to deal with, actually, even though it's made a big deal out of. That's not why it's big data, not because of the volume. It's big because of the other factors, velocity and variety. Velocity is the rate of arrival. Can you keep up with that data? And can you actually deal with data streams and so forth without losing too much data and without having to do a lot of reprocessing? And variety, which is the hardest one to deal with. How can I deal with a mix of these various data types? If you look at numbers out there, you'll see a lot of big numbers, right? So how much data we create every day, all that kind of stuff, how fast it's growing. When was the Watson one, I think? Yeah, by the way, Eric Schmidt was famous for saying, every 2 days we create as much information as we did up to 2003. He said that in 2010. The statistic that Google quotes now is every 2 days we create as much knowledge, as much data as was created up to 2 months ago by humanity. So from about 10,000 years ago, which is argued to be the start of civilization, to about 2 days ago. So, or 2 months ago. So this is sort of technically true, but semantically incorrect, right? Why, right? A lot of the data that gets measured here, when somebody like Google makes a statement like this, includes stuff that I don't call data, really. So, for example, what is the biggest source of traffic on the internet today? YouTube, right. Generally, video streaming. I don't count moving a video across the internet from server to client as data, right? So if you count that as data, these statistics are true. There are better ways of counting data, and I'll mention a couple of them. IBM Watson talks about 2.5 quintillion bytes, which is about 2.5 zettabytes. This metric I like a lot better, which is how much data, how much money is being spent on really storing data in the enterprise and managing it. And the important part in this graph is not the numbers, because the numbers, you know, this study is from 2014, and I'm sure the numbers are wrong already. However, basically, what you want to look at is the fact that enterprises have been dealing with unstructured data. In fact, the majority of the data in the enterprise has been unstructured for quite a while, right? Starting from 2010 onwards, unstructured data took over. Now, for sure, it's the majority of the data sets are unstructured. So the question is, how do you deal with that unstructured data? McKinsey Global Institute report basically said retailers in data analytics could save up to 60% or increase their operating margins up to 60%. US healthcare system could reduce costs by 8%. That was a claim made in 2011. If you look at what then McKinsey itself said in 2015, in revisiting this research, basically 3/4 of the retailers said, no, we got less than 1% improvement in margin. So the real question is why? Why was there such a high expectation? And the actual, what happened is not as expected. And we'll talk about that, of course. So let me start by talking about the variety of data. So I've grabbed here an example. This is a record that you might have at a bank about a customer. So you have a customer ID, age, gender, address, etc., and a few behavioral things, like have they applied for a credit card, have they expressed interest in something or another, etc. Today, you can easily go to places like LinkedIn and get all sorts of information about this person's job. That gives you also, by the way, a professional graph. In addition to Google, you can go to Facebook and get a social graph, which actually ends up telling you a heck of a lot about this person. and what they do and what they like and what their friends like, which ends up telling you a lot about their commercial biases. You can go to YouTube and Flickr and get all sorts of videos, images. You can get all sorts of articles, metadata, blogs, etc. about this person. So in no time, you can start with almost any database about people. All these data sources are pretty much free. You can get to them very quickly. And very quickly, you have a mess on your hands. You have at least 2 major graphs. You have all sorts of images, videos, articles, publications, actions like likes, all sorts of search results around this person. And the question now is, what do you do with it? Most organizations, if you throw this at them, in fact, I would argue almost all of them, will not know what to do. And in fact, many of you in the audience are very smart, and if I threw this kind of mix at you, I'm willing to bet that you would not know what to do. How would you leverage all this information together? That is a hard problem, yet that problem is upon us, right? It's available all the time. So what has really changed in commerce? Basically, the fundamental thing that changed that's causing the explosion in commerce is that the classical world of a transaction has changed dramatically. So it used to be what, when, where, how much, and what payment method was used. Today, there's a lot more context. Where are you? What is around you? Are you moving? How fast? Are you accelerating? Are you decelerating? Are you trying to park? Are you in good traffic or bad traffic? What's the temperature? Ambient sounds. Many of you don't know this, but your phone actually can tell a lot about you based on what sounds are around you. What is the exhaust, basically, the spectrum of information around you that's collectible by these devices that we all carry and love, these smartphones. So the graph, which is understanding location, surround, and intent, has become a big deal, right? Because once I know where you are, I can ask the question of what is near you, who is around you in terms of people, where are you heading to, what's on your calendar, what's on the way, what are you doing. A lot of the wearables tell you biometrics and so forth, so I could tell whether you're happy, stressed, working out, lazy, etc. All sorts of information is now surrounding what we used to call a transaction. That is another potentially huge opportunity. Of course, you have to be very careful here about privacy and issues like that, and we'll get to that. And of course, it all explodes with the Internet of Things. All these devices out there, what do they say about you? How do they identify themselves? How do they know who to report to? How do they know who they can trust, right? You've all heard about all the cameras now being used, the home cameras being used as a means to do denial of service attacks on websites because they can so easily be taken care of. So the whole idea of a perimeter in security has fundamentally changed in a big way, and how do we deal with it is the big question. So what should users of analytics in the big data world do? Well, the typical recommendation is build yourself a data lake. And while this is very useful and very exciting, here's an example from GE where they put a data lake together of all the jet engine maintenance data. And if you notice, they did it 2,000 times faster, 10 times cheaper. And there was a great celebration. Now, the real question is, and this is why I don't like data lakes, is what happens to this data lake 3 months from now, 6 months from now, a year from now, or 2 years from now, when the people who put it together disappeared? What is in it? Can you clean it up? Can you keep it up to date? Can you delete it? Let me tell you what happens in most enterprises. These data lakes will sit there, and they will consume their space, and they will sit there with nobody daring to even delete them, because God knows they might be valuable. Yet at the same time, we don't understand what the heck is in them, so we can't use them. So what starts as a nice, healthy data lake turns into a toxic asset in no time. And this is happening again and again and again in many places. And that's why we will talk a little bit about data governance, right? So a lot of thinking about it, a lot of this good work that happened over the years in database management systems and so forth has unfortunately been forgotten in the world of big data. And what's the story for making this new lake fit in with the old business intelligence and data warehousing infrastructure, there is no story today. It is not a good thing. It actually ends up causing way more problems than benefits. So there's a lot of things you can do about it, including data governance. But I like to use this example. So getting data out of a data lake is like shopping in a flea market, right? So you find an object, you like it. Is it the real object? Where did it come from? Is it stolen? What's the price? Is this the real price? I don't want to get it now. I want to set it aside. I'll come back tomorrow to grab it. Good luck finding it again, right? So what you find in a lot of organizations, though, including mine, is people load the data quickly because the technology is cheap, and you can load the data very quickly, and it can grab all sorts of sources, and you get all sorts of congratulations, emails, great job, team, you loaded the data. And reality is what happens next, right, is where the real problems start. So what does it take to make a data lake sustainable? Is this a solvable problem, or is this unsolvable? Is it possible to govern such a thing? How do people groups contribute in a rational way? What's the representation? Can you think, here's my first question to you, is there a real data lake out there that's healthy? Can you think of an example? Facebook, it's a reasonable example, but not great. But you're getting there. Actually, there's a data lake. I mean, at least I use one, maybe 2 to 3 times a week. It's by a company called Amazon. Now, Amazon sits on what I would argue is one of the worst data lakes on the planet, right? Why? Because most of the data, by the way, is not theirs and not controlled by them. That data comes in from retailers, distributors, wholesalers, users. All sorts of information gets dumped here. Yet, you go to a site like Amazon, and you can quickly search for an item. You can refine your search. You find the item, and miracle number 1, the image matches the text. Miracle number 2, the text is accurate. Miracle number 3, the price is correct. Imagine a place like Amazon getting the price wrong. It could turn into a loss in the billions in no time. And it works. You click on it, and you say, I want it, and it's delivered the next day or in 2 days or what have you. This comes from the nature of how Amazon is. And they're built, their DNA is a technology company. They know how to deal with data and data governance well. But in most other organizations, you actually need explicit data governance. So you need to be able to understand that the data must have an owner. The types must be well-defined. The data must be traceable. All that good stuff, right? Which a company like Amazon does well. You map it to a hospital, a bank, a government organization. All of these notions are pretty much foreign. In most organizations, you walk in and you say, who owns this database? You get the IT guy says, I'm responsible for keeping it alive. And then you say, well, I want to delete some content or I want to change it. Good luck finding the owner. Most databases, even though they're essentials, don't actually have an owner. And that's probably one of the first things you need to be effective and quick and responsive on it. So what happens is the result is data scientists who want to mine this data wind up spending all their time trying to chase data around, trying to clean it, trying to understand why there was a change in how the data was collected. Suddenly the attribute was redefined. Suddenly the scales are different without anybody telling you why. All that work that we call ETL and data management and data selection and so forth winds up taking up 90% of their activity. And we said they're very highly paid people. So 90% of their activity usually is wasted by stuff that you don't really need a data scientist to do. So technology people worry about to Hadoop or not to Hadoop. Hadoop started out at actually Yahoo. At the time I was leaving Yahoo, we put it out on open source. And Hadoop was criticized for a lot of mistakes. It was criticized for using commodity storage, because we didn't understand high-performance storage. File system instead of a real database underneath. And processors. If you were to use this thing for storage, the Hadoop architecture basically attaches a lot of processors to the storage. So a lot of companies criticize that as stupidity. Reality is, each one of these turned out to be one of the biggest economic strengths of the platform. So the fact that we use commodity storage allows us to do much cheaper storage. The file system actually provides all sorts of flexibility, dangerous but very flexible. And the processors, if you think about it, can eliminate one of the biggest problems in the enterprise, which is bringing the applications to the data rather than making copies of the data to bring it to applications, which is usually the source of a lot of problems. So storage, believe it or not, in a place like a bank, it costs something between $20,000 to $50,000 to store your data per year, per terabyte, on a data warehouse appliance. I know it sounds unbelievable. I have actually come across organizations where it costs $150,000 a year. Cost on Hadoop is about $1K a year. Still not super cheap, but significantly cheaper. There's at least one, perhaps two orders of magnitude savings. So that is a big deal. I am unaware of any company that has a diminishing data appetite. Every company I know or organization I know needs more storage next year than they needed this year. So this is a real problem, and it gets addressed by Hadoop. I don't know why this is repeated. The Hadoop Stack, of course, used to be a simple, nice thing with Hive and Spark and so forth. Today it looks something like this. I don't know most of the stuff that's on this chart, but some of it, I assure you, will become very important a year from now. I use this graph to just show you the whole debate in the database world between SQL and NoSQL databases. This chart is 6 years old. I used to use it as to say, look how ridiculous things got, right? Then I decided to check in on this chart. 2 years ago, it looked like this. About a year ago, it looked like this. Now, this is just choices of technologies of whether you want to query the data in a SQL or NoSQL way, structured versus column-oriented. So if storage is the biggest driver, what's the next biggest economic driver, do you think, in the enterprise? Any guesses? Processing cost, good guess, but not it. Security, another good cost, but it's a lot more mundane than that. Remember, storage cost was the first one. What would be the second? Organizing the data, getting closer, yeah. It's ETL, actually. It's extract, transform, and load. Believe it or not, people pay a lot of very expensive licenses to very good companies who produce ETL tools. The thing about big data is it actually lets you do this same operations, mostly for free, a lot more flexibly because it can work with videos and voice and images and all sorts of other things very well, and a lot of tools. And it takes you from the world of ETL to ELT, which is extract, load, transform, that's it. Now, why is that significant? Because that actually solves, I think, without knowing it, it solves one of the biggest problems in enterprise data. Typically, in an enterprise, you have the data warehouses and data stores, and you make copies of them because you want to build apps. And in a typical enterprise, you have hundreds to thousands of these apps, each of which the app engineer decides, I need my app database for performance reasons, for many reasons, ego reasons, whatever. So they'll make a copy, and then that copy goes out of sync with the big one, right? And soon enough, you walk into a bank and you find 1,000 apps with thousands of app databases. Hadoop changes this completely because those extra processors that were criticized as a bad idea, it turns out they enable you to bring the app straight on the data. You don't have to move the data around. No excuse for making that copy. That is huge. That can help solve potentially one of the biggest sources of data messes in the enterprise, which is a big deal. So let's use the remaining few minutes to talk about a few case studies, and then hopefully I'm going to get questions from you. I'm going to use one IoT case study that I borrowed from a friend of mine at Microsoft, Joseph Sirosh, and then 4 case studies at Barclays. So this one comes from Japan, actually, from Fujitsu. And it talks about the connected cow. So here's some cows hanging out. And they are wearing these pedometers, right? So why are these cows wearing pedometers, right? Is it like me, they badly need to take 10,000 steps a day to lose the weight? Well, the reality is every company, and now farms in the US and Japan and so forth are very small companies, are becoming big data companies. So what does a dairy farmer, what can they do? Well, the things they can do when it comes to the animals is detect health issues and detect them early. Oh, this is jumping ahead here. What's going on? No? Or improve cattle production, right? By detecting the right time for estrus, which is when, the magic time of the month when the cow is ready to reproduce. So it turns out this is a big factor, right? Detection rate for farmers in Japan is about 55%, which gives you a pregnancy rate of about 39%. If you can take the detection rate up, you can significantly increase the production, which is a big revenue driver for these farms, by the way. But this is hard because it occurs once every 21 days and lasts only for 12 to 18 hours. And unfortunately for the farmer and his family, it happens at night, between 10 p.m. and 8 a.m. So you have to be seriously motivated and stay up all night watching the cows to decide, which explains why they had the low detection rate. So how can they scale this? I love this picture because this is actually the picture of the actual data scientist and the actual Japanese farmer. I'll let you guess who is who actually started it all, right? So the reason I like this is because I did my Ph.D. at the University of Michigan, Ann Arbor, which is in the American Midwest. It's farm country. And this is basically in the early 90s, and I used to give community talks about AI, artificial intelligence, and invariably people would walk up to me and say, I didn't understand, what did your talk have to do with artificial insemination? And this is the first time when AI really meets AI. So I like this example. So here's the setup, and Microsoft is involved because it uses the Microsoft Azure cloud. But the idea is when the cow walks back into the barn, there's a router, it picks up the number of steps and sends it back to the world headquarters of the farmer, which is typically the kitchen table. And here's what happens on the kitchen table. You get this chart. Here's a normal cow, right? She walks around during the day, she sleeps at night, everything is fine. And here's what happens when the cow goes into estrus. She starts taking a lot of steps at night. So this actually gives you a very strong indicator that that cow is ready. And that gives you a 16-hour notice for the optimum time. So to me, this all sounds magical, but the next bit sounds even more magical. If you act just before the 16 hours, you get a probable female baby. And if you act just after the 16 hours, you get a probable male. So this, by the way, is being handled by a company that doesn't, a farm. What does a farmer know about data science, right? So it actually is a big deal, and it produced a lot of good results and so forth, 9% at the low end, 21% at the high end, et cetera. I use that example because it's a great example of how some of the smallest companies are making better use of data than some of the large ones. I'll have a few minutes for some Barclays case studies, and then I really want to take your questions. So we started with this chart in the beginning of the talk. I'll talk to you about how we used it for risk. Before that, I'll share with you a couple of public examples. So one of the first systems we built, actually Faizan Chowdary is probably in the audience somewhere, and his team built the first platform to do this. The whole idea was building a real-time decisioning platform, something that can talk to the databases in the bank, stream in events, and make decisions on the fly. So you can run prediction models and so forth. So our colleagues, we called that platform Fatafat. And Barclays Africa decided they want to use it. And they wanted to use it to predict whether a customer is going to go into overdraft. And what they did was basically send an SMS saying to the customer, in 2 weeks, based on your spending habit, we think in 2 weeks you're going to go into overdraft. Click here to do something about it. Now, normally, the response rate for something like this is about 1%. The response rate here was about 60%. So in an SMS campaign, 1 to 2% would be considered amazing. Here, 60% response rate. And of course, the NPS, which is the customer satisfaction, was very high. So Barclays talks about this, and they launched a couple of other areas where they tried to move more customers to the digital channel. They did credit limit increases based on real time. While you're in the store, you're trying to buy something, you get a message that says, Barclays card will increase your credit by this much. Click here to accept. And it's all based on sort of grabbing that data and deciding on the fly whether this is a good credit risk or not. Other use cases, so this is front office. Other use cases are things like KYC and AML. So it turns out that banks, by regulation, are required to do things like KYC, know your customer. But not only that, they need to know who the customer is sending money to. Now, most banks, I guarantee you, will treat this information as strictly a regulatory requirement. Now, if I happen to send money to another party, let's say I send money to Open Insights in India, that, sure, you have to check the parties and all of that good stuff, but you don't throw away that information. That information says, Usama has actually a commercial relationship with, say, somebody like a Faizan here. And here's the reason why they're sending money. So both of them now, you know a lot of information about both, and you can leverage that information. Using that information to turn it from just satisfying regulatory reports to actually saying, I understand the customer. And I used to have this program called From KYC to UIC, for Understand Your Customer, is a big deal. Same applies to fraud. When I decide on the credit card, is this a fraudulent transaction or not? Once I decide it's good, or I even make a call and make sure it's good, I now have extra information, which we call data exhaust, right? About this person. They're traveling, maybe on business, maybe personal, et cetera. So what can they do? This is strategically valuable, but in most banks, like I mentioned, they don't use it. Do you ask, is it connected to CRM? Does it help you understand the customer? Next time they travel, do you know what to do? And the answer in most cases is no. So that's the whole program from KYC to UIC. And we hooked it up with the financial crime technology team to address it. I'm going to skip this because we're running out of time. The other big applications were in Treasury. The Treasury is a place in the bank which is almost like the central intelligence agency, right? It has to understand how much balance is in each branch, what's the cash, what are the liabilities, brings them together pretty much every day. So it's a prime example for using big data as a platform. And the third one, which is strictly in the back office, is risk and finance. So here's an example of different application. Each one of them has its own stack of technology. Usually, one was Microsoft, one was Oracle, one was something else. And about 500 people working on this. We essentially automated it using the big data technology, and we're able to reduce the 6 stacks into 1. And that's a big deal because that reduces the risk, increases the accuracy, and of course reduces the costs dramatically. It's a big deal for banks. So real issues, in wrap up, real issues facing a data scientist. How do I get to the data? Very hard today. Where is the metadata? So now I found the data, what the heck does this mean? How do I get the data together? And how do I act on this data in real time? Remember that decisioning platform. How do I get the value fast? Lessons learned is the real economic drivers are economic, surprisingly, not technology. The flexibility and avoiding data movement is key. A lot more data than qualified talent. This is a real problem here, right? So you gotta address that missing talent bit, which I think is happening here. Drive the data efforts by the business needs is sort of our approach to it. And the dangers of data chaos can be afforded if you're really serious about data governance. And data governance sounds like a dry topic. It sounds like something I don't need to bother with right now, but it's very much like accounting. If you forget about it for 2 or 3 weeks, you are almost dead. You will never recover from that mess. So you need to pay a lot of attention to it. It's an evolving and confusing landscape. People confuse a lot of things like privacy issues with technology issues. I'm going to skip this here. My last slide is an advertising. We are hiring for Open Insights, so if you're interested, please send Faizan an email. And with that, I will definitely love to take your questions. So, thank you for listening. Any questions, please? Thank you. Yeah, please.
Totally new dimensions.
Yeah. So some would argue there is nothing new. Everything was invented by the Greeks. Some say the Indians as well. But look, the fact is, a lot of these basic issues are still unaddressed to this day. So rather than, in my opinion, the immediate need, if you're in an emergency room, you got to do triage. And the immediate bleeding and the immediate need is just, can I bring in enough people to understand what they're doing, and can I take care of the bleeding that's happening, which is databases are in a mess, data needs to be put together correctly, etc. Now, new directions, for sure, are in areas where you're using this, you're truly leveraging the unstructured data. So how do I use the graph coupled with images or voice, right? Voice data today, for example, has become suddenly extremely important. Why? Because a big source of cost for most companies is customer support and complaints. So customers call in, make complaints, it gets registered. Most of the time it gets captured wrong. Most of the time you have no access to what the heck the customer said. Every time they call, you have to check it 6 times. A lot of these problems can be addressed fairly quickly if you have the algorithms that do things like accurate text-to-speech, accurate indexing, and so forth. So dealing with unstructured data correctly is a big deal. As an example, face recognition. You talk to the researchers in machine vision, and probably around the time I was at NASA JPL, I would say, so late 90s. No, actually early 90s. From a research perspective, we thought the problem was solved. You give me a bunch of front-facing faces, and I give you recognition. No one has done face recognition at scale yet, even though the problem is actually fairly significant. Facebook came closest by trying to identify faces in images and trying to associate those with account IDs. And that's about it. Google has image search. The image search in Google, do you guys think image search in Google understands what's in an image? Yes, it's mostly based on the surrounding text, despite of what their CEO said recently 2 months ago. They are trying to launch new capabilities. But again, think about how primitive this is, right? If text about Usama Fayyad is surrounding some image, the image could be of a monkey, and it will decide, oh, that looks like Usama, right? So there's no understanding fundamentally in these algorithms, and that's where all the new research will work. Unfortunately, if you solve the academic research today, it'll probably take 20 to 30 years before it becomes sort of a mainstream use. But that's the story of research. Great question. Yes?
What problem I face usually is to convince management about benefits of any data science or any use cases. Because always they look in certain direction, what is my economic benefit, et cetera, et cetera. So what's your suggestion for this? How a data scientist can tackle this part?
Change management immediately. Probably by changing jobs. So look, awareness takes a while. And I think one of the biggest problems I see with data scientists, honestly, is data scientists do not know how to talk to business people. Now, you may be an exception, I don't know. But generally speaking, a business person, you talk to them about database and start talking about algorithms. By the time you say the A in algorithm, you've lost them, right? What you need to be talking about is, here's how I'm going to make you so much more revenue. Here is how your margin can be doubled. You're an idiot for not doing X, Y, Z, right? And then let them ask how. and then explain. And then typically they will say, aha, I got you. You're trying to just cheat me and get an investment out of me. And that's okay. That's a healthy discussion to have. The problem is the first part of that discussion isn't happening. The part that actually says you can actually do this and you can do it correctly and it doesn't have to cost you an arm and a leg. And that is the problem we need to crack. The problem today is most of the good guys who know how to talk to the business are sitting in big companies who, of course, have a big bill, ready to be made. Here's how much it's going to cost. Ah, you want us to look at your data? Of course. Prepare yourself. That is a problem we need to solve. And actually, I think some of it is being addressed here in the program where they're actually trying to mix some of the business communication skills and understanding sort of how to talk business strategy with this. But unfortunately, until the area matures, and it's still very immature, you still need to sort of explain it better and better to the business. So I think that's the key, is figuring out how to explain it strictly in business terms, right? I mean, a business will readily buy a server. They will buy a disk for storage. And they don't understand what the heck is in the server or the disk, right? But they understand I need it because it does this, this, this to me. They will buy software that does accounting. They get it because they get the business value. We need to now explain our products as data scientists in terms of business. And it's, by the way, it's very possible. And you will look like a genius when you do it correctly. Great question. Yes, please.
Thank you for your talk. My question was regarding the storage point that you mentioned, that especially in organizations like banks, you said that the Hadoop storage brought down the storage requirement by a certain percentage. I still feel that the basic transaction processing data, which holds the data, the processing operational data of the bank, would still need a system like an RDBMS.
Oh, yeah.
Yeah, so that doesn't change, and that data is growing still. So the storage reduction that you were talking about, which layer was it? Was it the analytic?
No, I'm talking about data warehousing and analytical databases. That's where the big costs are, right? Certainly doesn't cost that much to store transactions in an operational database. But the reality is, in an operational database, you can never use that information. So to use that information properly and be able to query it and look for patterns, you need to usually put it in a data warehouse and or a place that's analytical.
The copies of data that the users tend to make,
absolutely,
the multiple copies of the data. So that's what you moved into in Hadoop storage?
Well, you will have, yes. I mean, that's what I'm talking about, which is the data that you use for the analytics. That's why I said data warehousing appliance. So that cost was talking about companies like Netezza, which is now IBM, Teradata. There's many of them, Exadata by Oracle, etc. Those get very, very expensive.
Yes.
And those are the ones that I think the big data can actually address in very rational ways.
Sorry, and I had just one more question.
Sure.
Regarding the integrating the data, once you have a data lake, and we don't know what each of these pieces means. Somewhere I did read that Barclays was experimenting with the notion of semantic, attaching semantics to data, which is a new area of research, the semantic web. Was something concrete? Did you get some concrete output sort of going that route?
Yeah, so look, I mean, first of all, attaching semantics to data is not a new area of research. It's been around for a good 30 years at least. But again, it's another example of people not being aware of what was done before and not leveraging it for the longest time because they could get away with it. So yeah, in Barclays, as far as I know, those were some minor projects where we're trying to do this for reasons of reducing costs typically, meaning reasoning about the data for risk and or reasoning about it for compliance. But nothing at a major scale and nothing really that's sort of, just to be full disclosure here, it's not really research, right? It's really figuring out, can I apply this problem? And usually what works is you end up working with another company, usually a big one. When I was there, I was pushing very hard that we work with startups. So we had a whole program encouraging people to issue contracts to startups, and I used to actually give special bonuses to managers in my organization that actually had the courage to issue a contract to a startup, because it actually brings in some of the new thinking and the more economical approach to it. But yeah, I mean, those are usually the efforts. I think right now semantics has finally started breaking through because of the emphasis on AI and the need for machine learning. So if you want to do AI, you're going to do some reasoning. To do some reasoning, you need to understand what the data is about.
Correct.
Similarly, for machine learning, unless you're willing to spend a lot of money on data scientists foraging through the data, you better try to get the semantics right. And I think even before that, you better get your data governance right. Yeah. Thank you.
Doctor.
Sorry, was there a
question? Here, on your right.
Okay, one more question, I guess. So who?
Doctor, here.
Here and then here. Okay.
Sorry.
Yes.
So, Doctor, thank you for presenting those use cases. All were very knowledgeable, but the farm one was not just knowledgeable, but also very entertaining too. So my question, we already have a couple of questions regarding the applications of data science. I want to go back to a technology perspective of it. And you presented the entire landscape, and we can see how ridiculously complex it's getting now. So my question to you as a technologist is to understand how do I really, before the crowd gets it, get to a technology which is going to basically click in the market. Because I may go by jobs data, but jobs data happen post-fact. So is there any way we can really invest into technology which is going to get me a return on my investment?
So that's a great question. My answer to it is going to be indirect, but in a way I actually think is the only pragmatic answer, which is the investment in technology needs to be in simplifying something in order to make it scalable, right? Today, fortunately or unfortunately for the planet, almost everybody can afford to have a car. You get in the car and you turn on the ignition switch and it just turns on. Now, think about how much technology went into, maybe just even the fuel injector, or whether you need a spark to ignite it, or is it diesel, right? Huge amounts of theory, yet nobody talks about it, right? You just turn it on, and if it doesn't turn on, you complain and say, unacceptable, right? The same is true for many other technologies. People use Google search, and they have no clue on what's happening and all the processing and all of that. So I think the beauty of technology, and actually, in my opinion, some of the greatest engineering contributions is when you figure out how do you make it simple, how do you automate it, and how do you make it turnkey. So if we were to invest in technology, I would say that's where the highest payoff is. Figuring out how to simplify, how to explain, how to make robust, as opposed to here's another new algorithm, and it's so fancy, and it beats another algorithm by X or Y. That to me, and admittedly, I used to be very much into research, and I was Mr. Algorithms, but today I will tell you that's not what the planet needs. So at least in data science, we need that sort of simplifying force. And by the way, I actually think some of the most significant research problems lie in that challenge of simplification. Because simplify means I have to automate. Automate means I have to figure out what all the parameters need to be, and how do I set them, how do I make them robust, how do I deal with aberrations, all that good stuff, which is typically shoved under the table. Last question. A microphone is coming your way so that your layman question hits the audience.
Yeah. Layman's question in layman's language. You talked about data lake. I go a step further. Here's a data ocean. All the rivers and streams are discharging their outlet into the ocean. Can a stage come where the moment this water loaded with different minerals get discharged into the ocean, the data scientists immediately separate all that, store it, and in future, a particular mineral I am looking for, which I am not even aware of today, I can fish out and use it.
Yes. So will that day come? I am sure it will. However, we are indeed very far from it today. So what you are talking about effectively is automatic understanding of what's in the data, understanding even the anomalies, classifies them at least as anomalies worthy of attention, etc. And we are pretty far from that. I mean, today, look, I will share with you some of my, so I happen to be fortunate enough to deal with some of the I think some of the hardest prediction problems out there, just because of, I end up working with the right companies who have these problems. And typically I end up frustrating my team because the way I approach a data science problem is not by running algorithms at it, etc. We will spend a good 4 or 5 weeks just exploring data. Basic, boring explorations, just histograms, graphs, because what I'm looking for are all those anomalies. These big databases have huge anomalies. You know, the data about salary was collected under a certain scale, then it got changed. Nobody tells you that. And suddenly there's a change, or revenues, or whatever it is, right? Whatever metrics you're using. And unless you discover them, it's garbage in, garbage out. So I will gladly tell you, I look forward to the day. And by the way, this is not very hard to do, to automate, meaning I load the data, and it can do all these checks that I'm doing with my team, maybe 5 or 6 people working on one data set, looking at it from different histograms and so forth. A lot of this stuff can be automated. A lot of this pattern recognition can be actually sped up dramatically. Yet today, those tools are not there. So we are still in the primitive days. And we do need a lot of these basic tools. And some of the companies are beginning to think about the whole process. How do I manage the process of discovery and data science? And how do I measure progress and all of that? But it's a great question, and we're very, very far from achieving it today. Yeah.
So,
I think we are, I was instructed that we are out of time. So it is up, I will leave the control in your hands, whether to do more questions or not.
Ladies and gentlemen, we can entertain one more question. Yeah.
Just one question. So, Dr. Usama, thanks for the WNS, and the same problem we are trying to solve. And you also mentioned that in one of the slides, that while you were working with Barclays, you had the host of customer demographic information, for example, name, address, age, whether the customer has applied for the card, and then you have host of social media information for the customer. Now the exact problem is, for example, if for one particular customer you want to find the social media information, you can just go and Google it. But to take a decision at an enterprise level, and for example, you have 5 million records, 5 million customers. So you need to have a science so that you can match those customer demographic information or those particular customers with the social media information so that host of analytics can be applied. So if we are bearing that image, analytics, so what kind of how exactly you can merge the customer offline transaction, customer offline demographic data with the social media data so that you can come up with more insight?
Yeah, so how can you merge? I mean, it's a great question. And how can, that simple question of how can you merge is hard enough, right? So let's say I have your name.
Yep.
And maybe I have your date of birth if I'm lucky. Trying to figure out what is your Facebook account is not trivial. Just deciding. Because there's going to be so many matches on name and so many partial, and probably the birth date is wrong in Facebook or whatever, right? So just the basics of matching is hard. Now what we typically find in the experiments we ran, say at Barclays, with merging social data with our customer data. We have very good customer data. So I know your address, name, date of birth, all the good stuff that the government requires me to have. Trying to find you on Facebook, I end up having to rely on, do I have your email? And perchance, is it the same email you used for Facebook? Because that gives me the only guarantee. So even the basics of the matching, and we usually hit about a 30 to 35% match rate. So a lot of these basic problems can and should be solved, but I think to be solved, you need to start thinking holistically about the customer experience, meaning that identity, which is why I'm, for example, very, very passionate as identity as a service. Why is it that we carry so many identities and it's so hard to, unify these things together, right? Because Google wants you to have a Gmail, and Yahoo wants you to have a Yahoo email, and Microsoft wants you to have a Live, and whatever you have. So you wind up with this fragmentation in a space where, for convenience, it needs to be made the same, at the choice of the consumer, of course. So a lot of the basics need to be solved for this to happen. However, even with a 30% match rate, the insights we get are fairly amazing. And I think it's very possible to do insights at the aggregate level that are very, very telling of what's happening with your business, what's happening with your customers, and you can extrapolate to other customers based on that. So I think a lot of it can be done just with the partial matching and showing the data scientifically and finding the right metrics, right? And again, it's about finding the right metrics. So in a telco, for example, if you're trying to encourage them to create a wallet for cash, right? We actually use examples where we say, listen, in this particular region or country, customers who have a wallet tend to churn 20, 30 times less than customers who don't. That is something that a business starts paying attention to and say, okay, I got it. And that doesn't require completeness or accuracy or all of that. It just requires you being able to have a significant enough sample. Now, that infrastructure of putting the data together and helping present it in a way where the data can support you and people can't poke too many holes is not there. And it's being rebuilt, by the way. With every project, somebody is rebuilding that part of it, you know, in pieces. What we need is a way to sort of handle it in a systematic way where we approach it. I'm a huge fan of open source. I mean, it sounds like a great candidate for an open source project to sort of try to contribute to this to a point where you can solve the problem. But we are very far from it. Yep. And I think we are out of time. So thank you very much for your questions. Thank you for listening.